Good day, sir. My name is Tando Ngweba, and today I'm going to be doing my final presentation for Project 3. To take you through my project, at first I have the proposal here. My project name is a Smart Traffic Lights. Problem statement. During the instances of load shedding, traffic lights become non-operational, resulting in an increased frequency of car accidents. To address this problem, I have designed an intelligent traffic control system capable of detecting load shedding events and deploy a backup diesel generator to ensure the continuous operation of traffic lights. How will the solution address the problem associated with load shedding? The proposed solution ensures that the traffic lights remain functional during load shedding episode, thus minimizing the proportion of car accident attributed to power interruption, which is load shedding. Description of the project focusing on my design. This system employs a wide LED and a photoresistor for the purpose of detecting load shedding. These two components are strategically positioned within a compact enclosure oriented to face each other. Power to the LED is sourced from a 5-volt wall socket charger. Upon detecting load shedding, a relay module is activated to initiate the generator, represented as a DC motor. An ultrasonic sensor is integrated to monitor fuel level within the generator tank. With the data display on LCD screen and transmitted to ThinkSpeak via an ESP8266 Wi-Fi module, traffic flow is achieved using red and green LEDs and infrared sensors. An LCD is attached to a servo for user visibility, and the entire process is managed by the Arduino Uno microcontroller unit. To take you through the list of components that I've used to achieve this project, I've used Arduino Uno, 5-volt cell phone charger, white LED, LDR, which is a photoresistor, water level sensor, which is ultrasonic sensor, IR sensor, relay module, I2C LCD, servo motor, 9-gram RGB LED, ESP8266 Wi-Fi module, DC motor, 9-volt battery, Arduino Uno, and some wires. And over here I have the block diagram, the detailed block diagram for the proposed project. You can see I've used Arduino Uno as central processing unit, and you see the inputs is LDR, water level sensor, IR sensors, which is 2 of them, and I also have the voltage source 5-volt cell phone charger, which works hand in hand with this white LED, and then it gives the light signal to LDR. And I've powered the Arduino Uno with 5 volts from the laptop. For my outputs, I have the relay, which is connected to DC motor via 9 volts battery, and I also have I2C LCD, servo motor, 2 green LEDs and 2 red LEDs, and I also have ESP8266 Wi-Fi module, which is connected to my Wi-Fi and then to ThinkSpeak. Moving on to the schematic of this project, you can see here I have the Arduino, LCD, 2 IR sensors, LDR, ESP, and I also have relay module, motor, and 9-volt supply, servo motor, 9-gram, water level sensor, and the load shedding sensing circuit. And over here is my PCB for the whole project. And to move on, I'm gonna do my flow chart, of which is the one that controls the operation of the system. Here we initialize all the components. We set inputs and outputs. We connect to the Wi-Fi, and then we go to the main loop, of which it calls 3 functions: backup system, traffic lights, and diesel level. And then this loop runs all over and over again. First one, backup system. Here it is. We read LDR value. We test if there is light signal. If yes, we turn on the generator through the relay, else we turn it off through the relay. The second one, traffic lights. Here it is. We read IR sensors, both of them, north and east. We test if there is a car on north IR. If yes, we turn north traffic light green. We turn west traffic light red. We rotate the servo to face north, else we do nothing and keep the servo on default settings. And then from there we test if there is car passing on the west IR. If yes, we turn north red and we turn west traffic light green. we rotate the servo to face the west side, else we do nothing and keep the servo on default settings. And then we have the third function, which is diesel level. Here is, we read ultrasonic sensor, we test if the distance between the diesel and ultrasonic sensor is less than 5 centimeters, of which it indicates that the fuel level is empty, it is full. Then we turn off the buzzer, else we turn the buzzer on to alert the user that the diesel level. Okay, let me take you through the operation of this system. And you can see here at the moment the LCD is displaying the name of the project. And when there is cars on this lane, this LED needs to turn green and this side needs to turn red. But let's start from this side. This LED is green to open for the car that is coming this way, and this one is red to close this lane. And if the cars are on that side, it's supposed to turn that way, and the green LED here is supposed to turn on, the red LED here is supposed to turn on to stop the cars from moving on this direction. Okay, moving on, I also have the generator here. So what happens at the moment, there is no load shedding. As you can see, the charger is still connected to 220 volt supply, but as soon as I take it out, the diesel generator is supposed to turn on. And when I take it back, it switches off. And it's off. Taking it out, turn it on. Taking it back, it turns off. From there, I'm gonna show the part where I've used the ultrasonic sensor to check the diesel level on the generator. So if the generator is empty, the buzzer is supposed to make a sound. At the moment, the generator is full, so I'm gonna drain water to show that the buzzer will turn on. You can see that the generator is empty, the buzzer is making noise. But if I'm refilling it and it's full, the buzzer is supposed to turn off. I can see it's full now, the buzzer is off. And I also have my ESP Wi-Fi module, and it sends data to ThinkSpeak. Let me take you through the ThinkSpeak. You can see here is my channel. Here's the diesel level, and I also have the load shedding sensor. The values are being displayed here, and I also have the load shedding sensor. And as you can see, the last entry it says about a minute ago, and you can see it's recording another value, and it was recorded at 22:11, which is 22:11 same time, but this one is showing it in PMs. It's 10:13 PM, of which is the same time.